Solve each equation below. If possible, include a check for your equation. So this first one, we've used this technique called looking inside quite a bit. Um, Before I would look inside here, I really want to know what root 3x is, right? What is that? So I'm going to begin by adding 4 to each side. You can certainly make other choices, um, and as long as you make good choices and you verify that your answer works at the end, it's fine. So when I added 4 to both sides, I get that 3x is 9. Now, because I know, you know, my multiplication facts, and I know that if I square 9, right, 9 times 9 is 81. If I'm taking the square root of something and getting 9, that thing has to be the number 81. So my thinking right here is I can go two ways on this. I can square both sides of this equation. If I take 3x and then square that, if I square rather the square root of 3x, this becomes 3x. And if I square the other side, I get 81. But I can also look at it in terms of looking inside. This thing, right, this 3x must be 81 because it is the square root of 81 that equals 9. So this is a good place to land. And then I'm just dividing both sides by 3. It turns out that, yeah, you can write it as x is 81 thirds, but if you check out what that is, it is the number 27. So x is 27. And please, I mean, this takes literally seconds. If I grab my calculator and I'm going to go the square root of, so I'll open up the square root symbol, and I'll go 3 times 27. I will leave the radical, and I'm going to subtract the number 4. And when I press equals, this better say 5. And it does. So x is absolutely 27. 3 times 27, the square root of that expression, and then minus 4 does indeed equal 5. The other equation here, let's take a look at it. I'm going to use the distributive property to simplify it. This becomes, let's see, 2 times 3x is 6x, and then 2 times 7 is 14, and then I've got this plus 1. So on the one side, we have 6 times x plus 15, and on the other side, we have 6x minus 15. If I take away 6x from both sides, I get that 15 is the same thing as negative 15. Well, I mean, certainly they're the same in absolute value, but positive 15 and negative 15 are not the same. They're not, right? They're on opposite ends of the number line. So when we get statements like this that are contradictory, what this means is that there's no solution to this equation. These are actually parallel lines. They both have a slope of 6. One has a y-intercept at 15, the other one has a y-intercept at negative 15. So we would have to report here that there is no solution.